The next shape that we're going to go through here is a circle. And a circle is a fairly basic shape. A perfect circle is even tougher to draw, but we can kind of think of every single circle as being a perfect circle. So a perfect circle, okay, is one which has the same distance from the center of the circle to the outside throughout the circle. It has exactly the same distance from the center to the outside. So this right here is going to be the center of the circle, and if I draw out this length right here from the center to the outside, if I do that anywhere around the circle, it's going to be exactly the same distance. This measurement is also what we would call the radius of the circle, and I'm just going to put a little r beside the radius, as that's our measurement. Okay, so we use the term radius to represent the distance from the middle to the outside of the circle. Now, finding the area of the circle using the squares inside is extremely hard, as there are a bunch of partial squares. If you thought triangles and partial squares were going to be a challenge, circles are even more, because we have this rounded groupings, and it's just really difficult to try to find all of those pieces. So to find the area of the circle, we're going to have to use an equation. Okay, and so we're going to have to either know the radius, which again was that point from the center to the outside, or the diameter. Okay, so either the radius or the diameter need to be known. As mentioned, the radius is a measurement from the center of the circle to the outside, and the diameter is the distance across the circle which goes through the center. Okay, so it's a distance across the circle that goes through the center, and that is this length right there. So that's D. Okay, and we're going to call it D for diameter. Now, you might recognize here that the diameter is twice as long as the radius, or the radius is half as long as the diameter, and that is a way of solving for which is which. Now, a circle is associated with a specific constant. And a constant is a number in math that we know is the same no matter what. When we talked about polynomials, a constant was just a number kind of at the end. In this case here, a constant is a number that's never changing. It's always exactly the same. And we call this constant pi. Okay? It's not the delicious pie you can eat, even though that would be awesome, but it's pi. And we use this symbol here. It looks a little bit like that. You might have seen that in the past. You may not have, but we use this term called pi. And this is a value which compares the diameter to the circumference, which is the distance all the way around. I'm going to put a C there because circumference goes all the way around, of the circle. Now, pi is a constant. It's a number that's never changing. And the number that we have, it kind of goes on forever and ever here. And I'm going to try to get the exact ones down. It's on my calculator. It's 3.141592654. Some people try to, and then it keeps on going on and on. That's all it was on my calculator, and it just keeps on going. In March, when Pi Day comes around, if we're fortunate to be in school on that day, you'll see me wearing a shirt that has 100 digits of pi. They've tried to figure out what the actual value of pi is to the thousands and millions and billions decimal place, and they still haven't come up with the end. So it keeps on going forever and ever and ever and ever. This term right here, you can just use 3.14, or if you can find the value in a calculator, you can use that as well. Now, to find the area of a circle, we're going to do area is equal to pi times the radius times the radius. Okay, and so radius times radius gives us our units squared. So we're having 2 units. It's the same unit, but we use it twice. To write that down a little bit nicer, it will be pi times the radius squared. And that's how we can write down our equation for a circle. Pi of a circle is equal to area of a circle is equal to pi times radius squared. And that's going to represent our area. So I'll show you a couple examples on the next page just of how we find the area of a circle. Now the diameter, if the diameter is given, then the radius can be found by dividing the diameter by 2. So we can just take the diameter divided by 2. That gives us a radius, and then we can solve using that radius. Now, on one other little note here about a circle, which is a little different than other shapes, is that the perimeter, which is a distance all the way around, okay, can be found on any shape. We can count up the perimeter and figure out what that distance is. Now, on most other shapes, it's found by adding all the sides together. Okay, so on a square, we'd add up all 4 sides. On a rectangle, all 4 sides. On a triangle, all 3 sides. Circles are a little different. And so the diameter, the perimeter, which is also called the circumference, is found using this little formula. So our circumference is equal to pi times the diameter, or circumference is equal to 2 times pi times radius. They're both the same thing. Diameter is the same as 2 times the radius, and so we just plug it in like that. And so this would give us the circumference, or the distance around the circle. We're not too worried about this right now. I may ask the odd question about circumference, but we're going to get more into that when we start talking about area of 3D shapes, and then we definitely need to know how to find the circumference. So let's do a couple of examples here. We're going to find the area and circumference. We will do the circumference one there. So area is equal to pi times radius squared, and circumference is equal to pi times diameter, or 2 pi times radius. To find this area, we notice that we have the radius. Okay, so we have half the distance of the circle, or halfway across the circle. So we're going to use this one right here. Area is equal to pi times 3.8 feet squared. Now, when you're doing that on your calculator, there's 2 different ways to do that. Pi is the same as 3.14, and we can multiply by 3.8, and then we square it, or 3.8 times 3.8. And this gives us an area of 45.34 feet squared. We'll just round to 2 decimal places to make it nice and simple. Or you can do, if you have a pi button on your calculator like I do, I can punch that in, and then 3.8 squared, or 3.8 times 2.8, and you'll notice it gives very close to the same answer, 45.36 feet squared, which is very close to the same answer, just slightly off. But I would not mark either one of those wrong, understanding that the pi button compared to 3.14 is slightly different. Now to find the circumference, we're given the radius, so I'm going to use this circumference here, 2 times pi times r. It'll be 2 times pi times 3.8 feet. And our circumference is just a length. I don't know if you can see that there or not, 3.8. And this is then 23.88 feet. There is no squared units there. It is just plain feet. Okay, so it's just a length. Second one here, we're given the diameter. You'll notice that this is the diameter as it goes all the way across. So I'm going to find the circumference first. It's pi times diameter. And so it's pi times 15.8 centimeters. And so this is going to give me, and I'm just going to quickly do it on my calculator here, 49.64 centimeters around. Okay, so that's a length. So that's why we don't put the squared on there. It is a length. Now, on the other hand, the area, we are given the diameter. We need to know what the radius is. Pi times radius squared. There's no area formula using diameter, so we have to do diameter divided by 2, and 15.8 divided by 2 is 7.9. So this is our radius, centimeters. Sorry, I should put my units in there. And so this is pi times 7.9 centimeters squared. And if we do that, 7.9 squared This is an area of 196.07 centimeters squared, and that's using the pi button. If you use 3.14, you're going to get a slightly different answer. Question number 4 involves a number of circles. I want you to work on question number 4 and find the area and circumference, potentially, of circles.